All right, hello. It is May 16th, 2024. We're in the RxEnvironments.jl project with some guests from BIASlab and participants. And Wouter will be sharing with us about the RxEnvironments.jl package. So thanks all for joining. Looking forward to this presentation and discussion. Go for it.
All right, thank you, Daniel. So my name is Wouter. I am a second year PhD student in BIASlab. You may know BIASlab because we are the main authors of the RxInfer package, a package for reactive Bayesian inference. And last year, when I was working with RxInfer and doing, reactive Bayesian inference, I found that there was a lacking support for environments in the same reactive paradigm. And we were relying on reinforcement learning packages such as Gymnasium or reinforcement learning JL. And I didn't really like it. So I wrote RxEnvironments.jl, a package for reactive environments, which aims to complement RxInfer in the reactive um, agent development uh, ecosystem. So if we look at RxEnvironments, it's a very lightweight boilerplate package. It contains all boilerplate code to make something that I call a reactive environment. A reactive environment is an environment that consists of entities, where an entity can be an agent, but it can also be a component of an environment or the entire environment itself. And what we have to describe is how entities communicate with each other. So every entity has its own Markov blanket with which it can communicate with other entities in the environment. So in that sense, it's very related to active inference because, we have a very specific notion of the interior of an entity and the exterior of the entity and its Markov blanket. And I try to replicate that in RxEnvironments. So to give a short demo, we can dive right into the code. I have prepared the mountain car example in the documentation of RxEnvironments, but just to showcase to you that this gives you more flexibility to work with. So we have on the left-hand side, I have my code because I'm going to manipulate this environment in real time. And on the right-hand side, I have the environment. So I have my landscape. I hope you guys can see my cursor, by the way. I have the landscape, and in the middle, I have one agent, one car, a dot representing a car. What's nice about RxEnvironments is that I can send um, actions to the environment. So my landscape, the environment is one entity, the agent, the car is a different entity, and I can send a command that contains engine force on a scale from -1 to 1. So I can send -1 to the entity, and you'll see that the car starts driving up the hill. It doesn't have a lot of engine force, and I can live send different commands, and you'll see that the car responds accordingly. Now, what's nice about RxEnvironments is that, as I said, you'll get native multi-agent environments out of the box. So if I just add a different agent, mountain car agent, with some hyperparameters to the environment, you'll see that there is now a second dot at the bottom of the valley, a second car. And similar to how this first car can be controlled, we can control the second car too. Point one was maybe, this I should have maybe given this car a bit less engine power because it's clearly flying off the screen. But you get the gist, that we can control both cars simultaneously, and RxEnvironments handles all this communication natively, reactively under the hood. So my idea is, or my next steps for this project are going to be to incorporate it better into the RxInfer ecosystem, because I think that building agents with RxEnvironments in this way, that both the active inference community as well as the RxInfer community can benefit from this. So this is a very short overview of the things that Rx environments can do. It can do a whole lot more. But I think that this is a very short demo that gives you the best idea of why it's nice that we're going to go reactive, because you get stuff like this. We can control in real time. We can control multi-agent environments. And it's very active inference-y in that sense. So on that note, I'll stop sharing my screen. Let's see. And yeah, if you guys have any questions about this, which I heard you have, then I'll be very happy to take them.
Awesome. Thanks. Very informative and hilarious mountain car example.
Yeah, so, this you can play with this engine force of this mountain car, and I probably should have prepared that it doesn't fly off the screen, but I mean, it gets the point across, right?
Yeah. Okay. I'll share screen and just type, and so everyone else in the group just go for asking any of the questions we'd already identified or any new questions arising. So go for it.
I'm interested in the relationship between
I don't understand you very well. Maybe there's do you understand Cope as well? Okay.
Interested in the relationship between
You're very, very faint. Yeah, okay. Well, I think it was with this stuff. I actually had a question about not on this particular page that Daniel's sharing right now. I tried my hand at, let's say, plugging in the existing mountain car agent in the RxEnvironments documentation into your mountain car environment. I wasn't quite able to do that, but it appears that you have done that in that example just then. And then maybe I was missing something, because in the documentation, the RxEnvironments documentation for mounting car, I didn't see that there was an agent that had instantiated a generative model, much in the same way that the RxInfer documentation had. And I thought, oh, okay, this is a wrapper or a nice API for me to specify an environment. I now have to go away and then specify my agent also. But it seems, is that what you did for that example just then, or did you just
No.
Okay.
I just for this example just now, I just used my custom commands that I just sent myself. So this is something that I'm actively working on combining the two. The active inference mountain car example on the RxInfer website, I believe, is a bit cheating in a sense, because we give it all environment dynamics, all functions of the environment dynamics, and then we do some approximation to the posterior of what we have to do. But in a sense, it doesn't really discover that it has to do anything because it knows all the environment dynamics. So that's why I haven't really spent time on incorporating this specific example, because I feel that if we're going to demo this package plus an agent, that it should be an agent that actually has capabilities of exploring the environment instead of knowing all the environment dynamics and just, well, basically doing model predictive control.
Right. Okay. That makes it a bit clearer. Okay. I have a follow up, but I'll maybe let somebody else ask something just for now. Thank you very much.
So to give a very short answer to your question, we can sit together if we if you want to define an agent, a generative model. I know how to hook the two up. I just don't have a working example yet.
Right. Okay.
Because I don't want to use this. I don't want to use this agent from the RxInfer documentation, because indeed I feel that it's a bit cheating, but it's my personal opinion, right?
Yeah. Yeah. Okay. That actually clears a lot of things off for me, because I was kind of unclear. Like, oh, do I kind of plug that one in? Is that is that what I do? Yeah. Okay. But that's not that functionality
So
isn't exactly clear yet. Yeah.
we can. However, there is a subtlety there, and that is something that I find very interesting in my research. Is if you open up this space or you open up your environment to be reactive, then you want your environment to be able to um, receive an action at any point in time. So what we see in reinforcement learning is that you have a specific transition function. The environment waits until you send an action. It will move the environment forward a pre-specified amount of time, and it will emit to you an observation and a reward. However, if you make this entire thing reactive, then well, our agent would be able to emit at any point in time. And also it would be able to get an observation at any point in time. Now that is a very interesting setting to work with, because now our agents should kind of be robust to getting an observation at any point in time. Specifically, what if our agent that lives on some embedded device, on some drone whatsoever, it has less compute to do inference. However, well, at some point we're going to have to send an observation or an action back to the environment. We're going to have to do something. So this reactivity opens up a research avenue for, well, right now for me, because I find this very interesting, on how truly reactive agents would look like, if you see what I mean.
Yeah, I do. That's exceptionally exciting stuff. It's awesome. Okay, but okay, just to wrap up my
Yes.
question, there is no, at the moment you kind of manually,
Yes.
you put in the force limit and you say, okay, I'm going to kind of manually, play around with levers and so on.
I have working examples with like Bayesian thermostat or very, very easy, which I don't know if I have them on my machine right now or if they live somewhere. Like it works, but the thing that I got to work is model predictive control and not active inference yet.
Okay,
So that's why.
Awesome. All right. Thank you.
You're welcome.
Is my yeah? Can you hear me a bit better now?
Yes.
Okay,
go on.
Wouter, I'm interested in the relationship between Rx environments and RxInfer. For example, to put it simply, is it possible to use only Rx environments, or is it supposed to be always be used in collaboration with RxInfer?
So
As a
the
user, I
relation,
mean.
yes, the relation is that I wrote RxEnvironments specifically as a complementary package to RxInfer. So if you just want to do Bayesian inference, you use RxInfer. But I think if you want to build agents, that you're better off using the two together. So RxEnvironments is a package that uses the same reactive backend as RxInfer, so it's made to be compatible with RxInfer. However, if you write agents just with an algorithm, you can use RxEnvironments by itself. It's not mandatory to use RxInfer. They are separate packages. There's not a dependency on RxInfer. However, since they share the same reactive backend, so the same package for reactivity under the hood, which is also from BIASlab, which is Rocket. If you want to build agents, I would advise to use RxInfer. So they're disjoint, but they're designed with each other in mind, or RxEnvironments is designed with RxInfer in mind.
So if we use this high level of abstraction given to us by RxEnvironments, do we lose anything? Or can we at any time dive into the lower levels by means of RxInfer itself?
So I would say yes, because the inference process that happens in RxInfer is disjoint from what's going on in RxEnvironments, similarly to well, what happens in real life. So you can see Rx environments as a package in which you can make like a digital twin of the environment, but then whatever happens in the inference process in your agents, well, that's still RxInfer. Like all RxInfer diagnostic tools or debugging tools should be available there.
And a more practical question. I know from taste on the large papers and Professor De Vries as well, they like to divide the what's going on into these 6 methods: the act, future, execute, observe, compute, and slide. So, do you see that as kind of superfluous in the Rx environment setting, or is it fine to still use that approach?
Let me Google the definition for superfluous. That is I'm going to tread very carefully in answering that question. I don't think it is superfluous because in a sense that it's, if you want to design your agent such that it goes through those steps, then you're more than welcome to. My personal opinion is that I'm going to try and see if I can make an active inference agent that does inference in one step instead of having to act, observe, plan, slide, and so forth. However, for Rx environment, so for your environment, it doesn't really matter how you will get to your action, as long as, well, or not, right? You can send an action at any point in time, and if you don't send an action, the world will just continue. That, and Rx environments will just continue running. There's no real constraints on that. So that the design is to be as less constraining on users as possible, while opening up this reactivity, the reactivity aspect. And also for if you start with the package, you could make what I call discrete environments. They're a bit cheating, I would say, because they're basically just the Rx environments equivalent of a classical reinforcement learning environment, where you have a pre-specified time step every time. But I wanted to make that to make the transition easier, because if you go full reactive right off the bat, I would say it's a very ambitious thing to do. So I don't think it's a superfluous algorithm, but I also don't think it's well, Rx environments doesn't constrain you to use it. So I would say.
Right. Now, let's say one has a need to write one's own node in the factored graph. Would Rx environments support that kind of thing, or is it kind of an irrelevant question?
It's in that sense, I would say irrelevant, because a custom node is something that lives in RxInfer, and Rx environments really is concerned with everything that goes on outside of your inference process.
Then another quick question. While playing with the, I think it was a thermostat problem in Rx environments, I wanted to see the time behavior of some variables like observation, states, controls, free energy, and things like that. But it wasn't straightforward to me how to plot those in the Rx environment settings. Is there an example that you can point us to, or a fragment of code that shows us how to do that?
I can make it, because I know how I can access. So free energy is something that lives inside your agent. So it's part of the inference process. It's the cost function, if you will, of the inference process. So for free energy, you would have to look at your would have to look into RxInfer. However, everything that goes on in Rx environments, we can extract it and we can plot it. So both environment states as well as emitted controls or observations, we can extract all those things. I can show a code fragment that does this because it's, well, one line. However, I also understand that that is not something that, well, you probably remember after this meeting. So I'll make sure that we can design an example that showcases this. But in a nutshell, we can create a keep actor. So this is well, an entity that will keep everything that it gets. We'll keep it inside memory, and then we subscribe to the observations of the agent. So we say, well, subscribe to observations, and with this obs keep actor, we do this. And if I then call obs values, this will contain all kinds of, well, Rx environment observations, which is basically a wrapper struct for, let me call data on this entire array. And you'll get your individual observations. So we can basically tap anywhere in this process, anywhere in this communication. We can tap whatever is being emitted. So if I run this again, now it will contain 400 elements because, well, this environment is reactively running while we speak. So the agent is getting more and more observations. So you see this thing reactively growing every time I call or extract its contents. So there is definitely functionality in which you can sort of inspect this process. But yeah, I have to stress that it's really distinct from the inference process. So if you make an agent in RxInfer and you hook it up to Rx environments, then you have to set up a similar procedure to extract free energy and stuff like that from RxInfer. And because I'm not the author of RxInfer, I don't know how easy that is. But for Rx environments, this is one of the first things that I wanted to do, see what my agent was sending, see what my agent was observing. So I made sure to build it.
Yeah, I'm not sure if what you just showed was recorded by us. So if you could just make sure that that is included in your examples as well, that would be excellent.
Yes, that's my idea, that we can, I just wanted to showcase for now, such that you know that it exists, but it wasn't meant to be a big tutorial or anything. I can just put it in the examples, and then we can plot it. That's not a problem.
Okay, thanks a lot.
You're welcome.
Okay, anyone else can go for a question, or we have some other written ones, or I can ask a question.
I have a quick question.
I would just wonder, once, I don't know if you guys can hear me. I hope so.
Yes.
Fantastic. A lot of the examples that you have there, and kind of the way I'm probably naive in how I'm thinking about this. The Rx environment is modeling something in the real world, or at least that's the example that we're thinking of right now. Is Rx environments capable of essentially modeling more metaphysical spaces? So if you think of your question in a way that you have a time series or a space that you're trying to occupy, but it's not a physical space, it's a more theoretical space, dimensionality that you're trying to have an agent navigate. Is that something that you see that this is, usable for, or is this something that we need to kind of gear back towards the RxInfer package itself to kind of build the more metaphysical concept of the environment that you're putting together. Does that make sense?
So, yeah, if I understand your question correctly, yeah, my answer to that would be that there's no physics simulator or whatever in RxEnvironments. It's purely the boilerplate to make whatever you write act reactively and expose reactive streams that you can then use in RxInfer. So, for example, one of our colleagues has made an environment that returns the result of a stochastic differential equation. So an agent could query with an action, I want the realization at time t, and the environment would respond with the actual value. And with this interplay of querying a stochastic differential equation and getting a result, you can cast solving a stochastic differential equation, sort of a Bayesian state space model. I'm not an expert on this topic. I just know that one of our colleagues did this. So if I understand your question correctly, that would be the sort of environments you were after, or you were questioning about. So I would say yes, you can. So there's no physics simulator or anything in there, because that's a whole different topic. My main thing was just to make whatever code you guys write to make it reactive.
Fantastic. Thank you. No, that makes a lot of sense. I just wanted to clarify that, since
No, that's perfect.
not thinking so much in robotics or querying like physical environments, I'm thinking more along the lines of data environments. So that's why I was trying to understand how we could utilize this.
Yes, yeah, you can. Yeah, and you can push it further, right? You can make a combination of the two. You can make an environment that flies a drone. Your agent has to control the drone, but it can also query the environment for, hey, what is going to be my position in 5 seconds? So kind of this well, abstract action that's basically querying the environment. Well, since we have this mechanism that we can, depending on what action you send, correspond or match this with an observation, now you can do stuff like that. There's nobody stopping you doing it. Whether or not it's useful for your agent, well, that's up to you. I was just, yeah, I'm trying to make your environments as expressive as you can, or the framework as expressive as I can. And yeah, you can go wild with it, right? You can go crazy.
Yeah, that's perfect, because the agent that I'm wanting to put together would need to actually walk through time in a certain way, and optimize its activities in a time series.
Yeah,
and it needs to
I was already expecting you. That's why I brought up this. That's very cool. I would be very excited to see, well, whether or not you can build your environment in RxEnvironments would be, yeah, very cool.
Absolutely. I'll keep you updated then.
Nice, thanks.
The observable and actor roles in RxEnvironments. Can any entity take on either of these roles, or are there certain constraints? For example, let's say the agent must always have the actor role or something like that.
No, they're completely unconstrained. There is no real distinction under the hood between entities, or between something that represents an environment and something that represents an agent. They are both entities in RxEnvironments. The only thing is that you can make something which I call an active or a passive entity. By the way, all this terminology, it's all up for discussion. I've thought about this, and most of the terms that I come up with, they don't really fit what I'm trying to say. But an active entity is something that whenever it gets an observation or whenever it receives an action, it emits, or it at least considers emitting to its subscribers. For example, the mountain car environment itself would be an active entity. Whenever the agent sends an action to move the car, it will correspond or it will match this action with, well, moving the car. Whereas the agent, whenever it gets an observation from the environment, well, it doesn't really have to do anything. We have to, in a later stage, attach an inference process, but that is something that's not Rx environments. That is RxInfer. So we make this entity passive in a sense that it's an observer that can also send actions, but those are not triggered by an actual algorithm that we write ourselves in Rx environments, but it's a result of some inference process. It's the triggers are external to the reactive ecosystem that we've built in Rx environments itself. So that's the only distinction that I make. But you can, something that represents an environment is something that represents an agent. They're under the hood completely the same things. They're just entities that can communicate with external entities.
Do you think you could, in addition, add a discrete control space example for us as well? Because mountain car and the Bayesian thermostat are both continuous examples.
Sure.
Even if it's just a simple discrete control space, or categorical in particular, categorical control space, maybe a simple maze example or a grid example, like the windy grid that's often used in reinforcement learning. Even if it's just a simple windy grid.
Windy grid.
Yeah.
Okay, I'll Google that.
But just even if it's just a simple categorical control space, because that's what our problems currently center around.
Okay.
Not so much continuous control spaces, but categorical control spaces.
Okay, that's I can do that. Okay, I see. Windy grid world. Yeah, okay, I can do that.
That'll be excellent. Thanks a lot.
I ask a sort of a very quick, broad question about the whole ontology bit. When I first learned about this, my own naivete and just sort of looking through the docs, I thought, oh, okay, this is a wrapper around RxInfer for standardizing the creation of an environment that you will then use for whatever purposes. But it sounds to me it's not at all that. It's really this is not even really a way of talking about an environment per se. This is
it's more of a it's a communication protocol for active inference agents, I would say.
Yeah. It's like, well, this is a way to sort of standardize the dyadic interaction between two abstract entities, and that could be between environment and an agent, or it could be something else entirely. That's much broader than what I was conceptualizing. Excellent.
So when I started this, indeed, I started as, okay, I want to standardize environment creation in our ecosystem in RxInfer. And I had discussion with Magnus Kudal, who's also in this Discord I saw. And well, we had some very interesting talks. And he said, well, actually an environment and an agent, they're not so different, right? They just receive data from each other and handle them accordingly. So yeah, there is a certain symmetry there. And then I thought, well, if there's a symmetry there, then I can make an overarching programming concept and just kind of implement it that way. And that's what I did. And then it turned from just a way in which you can make an agent and an environment communicate to a package in which you can communicate this whole network of subscriptions and communications, because there's no constraints anymore. So, for example, we run an environment in our lab with Mafco actually that has a non-trivial entity interaction where we have a hearing aid that gets data from both the external world, because it has a microphone and it should register the external world, but it can also get data from the user of the hearing aid, saying, hey, I'm happy with the hearing aid settings, yes or no. So now we have a 3-entity environment. We have the user, we have the hearing aid, and we have the external world that just emits noise. Then we have a 4th entity, which is our agent that should learn the preferences of the user, that should get data from the hearing aid and should tweak the parameters inside of the hearing aid. So now we have 4 entities that are communicating in this non-trivial way, and well, we built this in Arcs environments and it all holds up. Like it all just, it runs. Just because whenever we get data, the hearing aid knows, I get new data, I get new noise. I have to transform this noise and send it to the user, and I have to do a Fourier transform and send it to the agent for analysis. And just because it does this reactively, it's all tractable and all works nicely. So it turned out to be a bit of a bigger, scope than I would have imagined. But I'm not making any claims on how large it actually is. That's
Cool. This is also very cool, and I'm very, very thankful that you're working on this. Because I had the thought like, oh well, what then is sort of predicated of the environment? It's kind of like, well, we have the environment and the agent, they're kind of both being equally treated here. So
yeah, it's a very interesting question, right? So what is the actual difference? Some people say, well, an agent has some sort of inferential process on how it comes up with an action, but in a sense, well, we are all just with our eyes and ears and muscles. We have an interface to the environment, but yeah, in that sense, we are just all Markov blankets with internal states that navigate this world, and this communication that we have with our outside world. I try to replicate that.
fantastic.
Thanks. Anyone else
I
want to
have a-
ask any questions? Yeah, Christoph, or
Yeah, I have a question. I didn't quite get what you said about the difference between the typical reinforcement learning setting and the RX environments. Could you explain that again, please? That was very interesting.
Sure. If you want, or if you make an environment in gymnasium, we can look at their documentation, right? So let's see, gymnasium package. So I go to gymnasium and I want to make my own custom environment. I saw it here. Make your own custom environment. I've visited this page before. So we can make our environment, blah, blah, blah. And then you have this function, step. The step method usually contains most of the logic for your environment. It accepts an action, computes the state of the environment after applying that action, and returns a 5-tuple observation, reward, terminated, truncated info. So we write a function, step, that takes only an action. So this is the main design paradigm of GYM and most reinforcement learning packages, actually, where I emit an action. This action is incorporated into the world, but the time that the environment is stimulated forward is constant. So there's no notion of different time intervals. Whereas if I'm a very big football aficionado. For the Americans, that's soccer, but it's actually football. Yeah. But if I kick a ball, I kick the ball starts rolling. Well, whether or not I do something, the ball will just continue rolling. Like this environment around me, it doesn't wait for me to emit additional actions, or I'm not consciously saying, okay, for the next second, I do nothing. And then the ball rolls. Okay, for the next second, I do nothing again. And the ball rolls further. No, there is In the real world, there is a difference, right? We do something and then the world just continues. So we can do something at any point in time, and the world around us will just, well, the world keeps on turning. And that's what I was trying to do with Rx environments, is to alleviate ourselves of this communication protocol, because this specifies I get one observation, I can do one action per observation, and that's it. And in between different observations, I have no power to do anything whatsoever. Also, if I have an environment that instead of modeling 1 second forward, I now do half a second, well, everything breaks down, because now I have to emit actions at twice the speed, or my observations don't correspond anymore with my internal model, or there's all kinds of stuff that if you do it like this, it turns kind of awkward. And that's what I was trying to alleviate with Rx environments, is that I'm trying to make this communication between agent and environment as free as possible. So
Right,
if you
right.
have a hearing aid environment,
So,
that you can, that's it. If I'm not, I'm rambling. Sorry. Good that you interrupted.
That's a good explanation, and I think you also mentioned something about some difficulty there, because the question then becomes, like, if you have multiple agents interacting with the environment, then what exactly is the state of the world, right?
What exactly is the state of the world is not because you can just sort of, you can have like a God entity that takes care of this stuff, that kind of resolves all conflicts in that sense. The main question for me would be, well, we just took away your one moment to conduct an action. In reinforcement learning, you have one moment, you can do an action, and you'll get one observation. We just took away this one moment and gave you the opportunity to act at any point in time. Well, when are you going to do it?
Right. So, the reason I'm asking about this is that it immediately got me thinking about Stephen Wolfram's work on observer theory. So he's trying to formalize the notion of an observer, right? And there is this whole field that he basically invented for the physics project related to which calls multi-computation. I'm not really deep into that yet, but it seems somehow relevant. As an agent's interacting with the environment, we effectively sample it precisely because it keeps rolling as we do the internal computation required to update our generative model in order to act. So I think you stumbled onto something quite profound there, and the question is about this God mode view, right? Like that's an old question in physics, whether there exists the absolute reference frame or whether everything is relative. And just want to say that, food for thought. There's some interesting problems there. Maybe we can talk about it sometime. I would love to hear your thoughts about this.
Yeah, sure. Like I'm very interested in this stuff. So as a software developer, like I would advise you in your environments, if you're not dealing with, existential stuff, that just make a God state that takes care of this. But you make a very good point, right? So if we really want to make an accurate representation of the world, do we need this God state? Or because we now allow our environments to alleviate this, right? We can have multiple entities that together compose the environment, and then there is some internal communication between them. So it does open up this door. Like it doesn't slam it wide open, but at least there's a, in Dutch you would say open kier.
Yeah. So
There's
like
no Dutch people.
I think there's a that's a potential incursion into effectively resolving some of the most interesting problems in the fundamental theories of physics. The understanding precisely which one is the case, whether it is this absolute reference frame, or whether you can just simply explain everything through these relative reference frames and agent sampling the environments. And if you can effectively recover something that looks like physics from this interaction, which is what Wolfram is essentially working on, that would be a complete computational fundamental theory of physics. And it's a big undertaking, but it's worth considering, not just merely from software engineering perspective, but from from that angle if you're interested in that kind of stuff.
I mean, yeah, it's very interesting. It's something that, it's a very big deviation from what my supervisor wants me to work on. So it's probably not something that I'm going to undertake. But yeah, if anyone wants to pick it up, right, who am I to stop them?
Thanks.
Cool.
It's great work.
Cool. Yeah, anyone else want to ask any questions? How would you deal with the setting of multiple ant nestmates moving around and modifying the pheromones on the ground? So in these kinds of simulations, it's common enough to have the pheromone state on the ground and then nestmates that are reading and writing. How do you deal with the spatial proximity and the collisions and interactions?
So that is something very, very, very difficult. I'm working on a project right now where, once again, we're modeling football, which is why I brought up this example just now. And like resolving collisions is something extremely difficult. It's something that I don't have a standardized advised way of doing in RxEnvironments, just because game studios they spend God knows how many developer hours on resolving collisions efficiently. So that's not something that I think, well, we can figure out in an afternoon, right? It's something that would be in the internal dynamics of your environment, but not something that is part of your communication protocol per se. It just influences the type of observations that your agent would get. So it's not something that I can give, that I feel qualified to give advice on. But it is like making this environment with ants running around the floor. That is something that's just a multi-agent environment. That's fully covered. The problem is the collisions. That is a difficult thing. It's not difficult in an RxEnvironments perspective. It's difficult in a computational geometry perspective that you want to resolve collisions. That's, yeah, like in AAA games, you can still clip into walls somewhere.
That's a great and funny response. Yeah, I would just highlight the real structural difference when you pointed to the step function in the gymnasium. That
Yes.
is why in so often for these control problems, there's like a null action or like a wait action. So you kind of get this bimodal action vector, policy vector, where there's like a do nothing option and then all the options. Because out of requirement, something must be emitted at every click of the simulation. And all of a sudden, it's like we moved from walking on a staircase to like ice skating or flying with RxInfer, because it has totally opened up a dimension of the control question when
Yes.
to act, not just
Yes.
which with according to a metronome. And that's an entirely different approach that the communication protocols enable, and then those communication protocols can have all these other functionalities, like they can have a sub-ontology or they can have compliance features as well. So it's super powerful, and we're very excited to learn it.
That's the main point. It's two sides of the same coin. Like it opens up this communication protocol, but then you have to question when. When it's something that I'm going to spend time on in my next project. Like, can we make an iterative procedure, maybe with iterations and RxInfer, that we can send the intermediate posteriors, and we always have like an action that we supply. I don't know yet. I have no idea. Or I have ideas, but I don't have anything working yet.
I think to me, the underlying principle of the RxInfer suite versus traditional RL is this instead of having synchronized communications, we now have asynchronous communications between everything.
Between everything, yes. Yeah, I'm glad I got that point across. That's the point I wanted to make.
Great. Well, if anyone else has a question, otherwise we will continue learning and watching the GitHub updates and just building out examples, because in the coming months, we know a lot of fun things will happen.
All right. Yeah. You guys can always reach out to me on, I don't know, GitHub, Twitter. I don't know how often I'll check Discord. I'll try. I'll try. But you can always reach out to me on LinkedIn, Twitter, whatever. That's all fine.
Excellent. I do have a final question, if that's all right.
Sure.
Just with respect to future directions and that kind of thing. What's kind of the biggest set of problems? What are you kind of looking to do? I know that's a massive thing, but is there anything relatively summative in that direction that you could perhaps speak to for just a second?
So I'm very interested in this when to act problem. So this to me opens up the door to an agent that because so we can now act at any point in time, or at any point in time, we can send something to the environment. A logical consequence for me is that at any point in time, we should have an action ready to send. So when the next observation comes in, we don't know when that's going to be. We should be able to act. So we have a certain computational budget between one observation and the next. We don't know how much it's going to be, but we do have a budget to spend. So I want to design indeed an iterative procedure that comes up with an action and then refines it and refines it and refines it until, the next observation comes in. So we have to send whatever we had and we get the next observation. This gives you, if this all works, right, this gives you a very nice, robust agent that if you give it a lot of computing power, a lot of computational budget, then in between observations, it's going to be able to come up with a pretty good action and will solve the task accordingly, like ideally. However, if you limit this this computational budget, you put it on like a Raspberry Pi or on an edge device, it will not have as much iterations to refine its actions. So it will still solve the problem, hopefully, but it will be less efficient doing so. It will be slightly dumber. So this is to me, it's a very interesting problem to think about, because then you have a sort of a procedure for control that is robust to loss of computation or whatever, and it's still adaptive and reactive and all those nice things we get from Bayesian inference. So yeah, that's something that I would want to work on if I had 48 hours in a day.
It's very interesting. So it sounds to me like the number of iterations you just referred to is the iteration field in the call of the infer function.
Yes.
In ActInf.
Yes, if I can do something like that, so I run an indefinite amount of iterations and I just stop the inference procedure whenever I have to do something, and then I extract the latest posterior for the action and I send that to the environment. Yeah, that's something, that would be the first thing I would investigate.
Yeah, I certainly think it has the potential to make the behavior in general quite robust if you consider that approach.
It would be robust. It would always have something to do, like it would always do something. Whether or not sort of the free energy would converge as a measure of whether or not this action is good enough, that is to be investigated. But it would allow us to run the same models on edge devices as well and get slightly worse performance, but still, it would still do the job. And then you can investigate, how many iterations do I actually need before I can solve the problem. It's of course problem dependent, but it's it's just something that really interests me. I really like this way of thinking, and it's in part why I wrote this package, because I don't like this synchronized communication protocol from Jim. I just don't like it. Yeah, that's why I wrote Rx environments.
I think the only alternative is to not be able to respond whenever it gets an observation. In other words, to postpone your response. And then
Yes.
it nudges back into the synchronicity approach again. So it breaks away from the the reactiveness of the whole paradigm.
But then you run into the robustness issue, I would say. If you have a self-driving car and it's driving into a wall because it thinks it's a green light, because those things are not that smart nowadays. It figures out it's a wall, but it takes some time to adjust, or it takes some time to come up with the idea, okay, now I have fully converged on the action that I have to steer away. Well, by that time we might have already crashed into the wall. So this queuing up of observations and waiting until my computation is fully converged, I think it takes away the robustness. Like if you don't have enough computational budget to spend, well, yeah, you might do the wrong thing. It's the same as when you and I are in a car, right? If we're in a very busy situation. So, well, I'm in the Netherlands, so we have cyclists, right? So if we have cyclists, we have other cars, and there's an ambulance coming, it's very busy, you might feel overwhelmed, but you still kind of know the basic things to do to steer your car. It's basically the same where you have limited computational budget. There's all this stuff around you. So to come up with a really thought through response or action, it's too much to ask because you don't have the computational budget. But your brain kind of prioritizes. It says, well, if we stay on the road and we let the ambulance pass, and well, we're fine for now. This is the best we can do. So this feeling of being overwhelmed by what goes on around you inspired this idea of robustness and of interruptibility, basically.
It makes a lot of sense.
Yeah, but then again, how I'm going to do it? Well, no idea yet. Or run RxInfer iterations and see if I can send intermediate posterior results or something. But it's just something. Yeah, I find this very, very, very interesting.
I think it's a good thing that free energy in general decays predictably in a sense. So, I mean, just fully using your budget, your computational budget for the time that you're allowed before the next observation arrives, I think it's fairly safe to just
Yes.
use the current value of the posterior. That's the best you can do under the circumstances.
Yes, that would be the argument, indeed. And hopefully this opens up the road to having actual, robots driving around instead. Because, well, there's no self-driving cars where I live. There's no robots or drones flying around, and I think one of the reasons is because they're not robust or interruptible.
Fully agreed. Yeah.
All right. Thank you all. We'll look forward to staying updated asynchronously, even.
Asynchronously, reactively.
See y'all soon. Bye.